Have you ever wondered about the amount of space debris floating around our planet and its potential impact on future space missions? The cosmos, once an untouched expanse of space, now mirrors a galactic junkyard, teeming with over 500,000 pieces of human-made debris. This collection of space junk, a byproduct of our space explorations, includes defunct satellites, spent rocket stages, and fragments from disintegration, erosion, and collisions. Why is this a problem, you might ask? Well, imagine hurtling through the cosmos at breakneck speeds, only to collide with an unexpected piece of metal. These debris pose a significant threat to the safety of astronauts and spacecraft alike, due to the high velocity at which they orbit the Earth. A collision with even a small piece of debris can cause catastrophic damage to a space mission, making this issue one of the most pressing concerns for space agencies worldwide. But, as you might expect, scientists are already devising ingenious methods to tackle this problem. So, what exactly is space junk, and how did it get there? Let's start by defining space junk. It's basically human-made debris floating around in the vast expanse of space. This debris can come in various forms, from defunct satellites that have served their purpose and are no longer operational, to spent rocket stages left behind after launch. It also includes fragments resulting from disintegration, erosion, and even collisions in space. Space junk is not always a result of recent activities. It's a collection of remnants from over 6 decades of space exploration. You see, since the dawn of the space age, we've been leaving bits and pieces behind. Every satellite launched, every mission to the moon, Mars, or beyond, contributes in some way to the accumulation of space debris. So essentially, any object in space that no longer serves a useful function, big or small, qualifies as space debris. But why should we care about these floating relics of our space exploration history? It's easy to dismiss space debris as harmless artifacts of human ingenuity, but the reality is far from it. This orbiting refuse poses a serious threat to both manned and unmanned space missions. Imagine a tiny piece of metal, no bigger than a fleck of paint, hurtling at speeds of over 17,000 miles per hour. At these velocities, even the smallest fragment can cause catastrophic damage to satellites, spacecraft, and space stations. But the danger goes beyond isolated collisions. Welcome to the concept of Kessler syndrome, a scenario where the density of objects in low Earth orbit is so high that one collision could set off a domino effect. Each crash creates more debris, which increases the likelihood of additional collisions. It's a catastrophic chain reaction that could render space exploration and even the use of satellites untenable. Clearly, space debris poses a serious threat to our future in space. But what can we do about it? Enter the concept of trash-blasting lasers, a proposal that sounds like it's straight out of a science fiction novel. In the quest for a cleaner cosmos, researchers have put forth a rather futuristic solution: the use of satellite-mounted lasers. But how exactly would this work, you might ask? Picture a laser mounted on a satellite orbiting Earth. This laser isn't for show, it's on a mission, a cleanup mission. Its target? The hundreds of thousands of pieces of human-made debris hurtling around our planet. The laser's goal is to blast these pieces of debris with such force that they change their orbit, descending closer to Earth. As they re-enter Earth's atmosphere, the intense heat causes them to burn up and disintegrate, effectively cleaning up the cosmic clutter. But it's not as simple as pointing and shooting. For this method to work, precision is key. The laser stations need to match the orbital measurements of the debris accurately. This means knowing the exact altitude, velocity, and direction of the debris at any given time. This proposal, though still in the theoretical stage, is gaining traction, especially in countries that have contributed significantly to space junk. For instance, China has shown a keen interest in this laser-based approach, likely because of its substantial contribution to the space junk problem following a 2007 anti-satellite missile test. The idea of cleaning up space with lasers may sound like a plot from a sci-fi movie, but it's a real proposal being seriously considered by scientists worldwide. It's a testament to our technological advancement and our commitment to safeguarding our space environment. A solution to the space debris problem could be as exciting as the exploration of space itself. While the concept of using lasers to clean up space debris is exciting, we're still some way from seeing it implemented. This isn't just a case of pointing a laser at a piece of debris and firing away. The process is complex and comes with its own set of challenges. One of the biggest hurdles is the need for international cooperation. Space is a global commons, and any cleanup efforts would need to be a multinational endeavor. This means navigating through a sea of international laws and treaties, not to mention the potential political tensions that could arise. It's a diplomatic tightrope walk, but one that is necessary to ensure the safety of our space missions. The technological challenges cannot be overstated either. The idea of lasers blasting space debris into smaller, manageable pieces sounds straightforward, but in practice, it's anything but. Matching the orbital measurements of the debris with the laser stations, for instance, is a task that requires precise calculations and state-of-the-art technology. And while we have made great strides in laser technology, we still have a long way to go before we can effectively and safely employ it in space. Now, let's talk about China. China has shown a keen interest in this approach, especially given its significant contribution to space junk from a 2007 anti-satellite missile test. This could be seen as an opportunity for China to take a leading role in space debris cleanup efforts. Yet, it also raises questions about the potential misuse of such technology. After all, a laser powerful enough to blast space debris could also be used for less altruistic purposes. So, as we continue to reach for the stars, we must also remember to take care of our own cosmic backyard. The road ahead is filled with challenges, but with international cooperation, technological advancements, and a commitment to preserving the space environment, we can look forward to a future where space debris is a problem of the past.